Now it is my pleasure to be able to introduce a couple of my we have a number of environmental employees. But up here we have Sarah Holcomb from the Surface Water Quality Bureau and Courtney Perkins are now going to show us all how this ISCO sampler works. And this is a piece of equipment that was purchased from funding that the Environment Department receives from the Department of Energy. And so you guys are up, you're the experts.
Okay. So this R2D2 looking machine here is an automated water sampler, and it's also called ISCO, so you may hear us refer to it that way sometimes. What this does is, because it's automated, we can set this up in the channel, and we can extend the tubing here into the bottom of the channel in order to collect stormwater as it comes running down the canyon. So we do set it in to make sure that we capture the entire storm event. So we want to see what the flow is like during the entire storm. And Courtney is going to demonstrate how we actually operate the sampler.
So, like Sarah said, this is an automated water sampler, and so we can program it. So we don't actually have to be in the field when it's pouring rain and the canyons are flooded. So that's pretty nice. That's a nice way to go. So we program these to set them in the canyon, and they detect water. So most of the canyons up here are dry. They don't flow very often, but it'll detect when there's water flowing in the canyon, and it'll tell the sampler to start taking samples. And what it does is there's a pump right in here. This is the smart part of this. This is the computer part. If we're R2D2, this is what we talk to you. Here's the pump part and this tubing that runs down into the channel. So when it detects water, it'll turn itself on, and there's this part down here, bottles in here, which you'll see in a minute here. So it'll detect water and it'll turn on. We're going to turn it on for you. It's pretty loud, just so you know. So we're going to turn it on and show what it would be like to collect a sample out of the channel. Just collected a sample in here. I know it's kind of loud, and just for so you know, we do have some water back here that we're pulling. It's not water from one of these canyons, just so you guys are aware. But we'll show you what happens now. So we've collected one bottle in here. Yep, got it. And so what would happen is this would get triggered, and it would fill up all these bottles in here. And like Sarah said, we try to collect all of that storm flow. So when we get our monsoon rains, these canyons flow really hard and the water's really turbid, it's really like chocolate milk. We're trying to collect all of that because all that chocolate milk color is sediment in there, and that's how we see contaminants move up here. So that's what we're looking for in here. So we try to collect through that whole flow event. So we'll fill all these bottles through the whole event, and then we'll come and check them the next day. And we come out, we cap them all. Usually they're really muddy and messy, so this is a nice clean example for you. This is a brand new sampler. So this is just an example of one bottle that we filled. So this would be filled with storm water that's coming down the canyon. So we'll fill this whole set. As you can see, we have the little bottles here. These glass ones are for certain analyses. We'll look at PCBs in here.
PCBs?
PCBs, polychlorinated biphenyls. Those are it's a solvent and it's ubiquitous, so you see it. You see it in a lot of places. It drives a lot of requirements at the laboratory, and there are permit requirements for environmental cleanup. These plastic bottles we'll look for explosives in, we'll look for radionuclides, we'll look at metals in the water, and in fact aquatic life once this water reaches the Rio Grande. So that's an example of how these samplers work.
Good job, guys.
Excellent.
Okay, well, that concludes our event today. I want to thank everybody for coming. Thank you, Governor, for coming out to Los Alamos, and thank you, local officials and DOE officials.